All right, so number one is talking about motor efficiency. And on the y-axis, you have the efficiency in percentage points. So that's important to look at. And on the x-axis, you have current, which is measured in amperes. So the first one says that it's most efficient. The motor uses 50% of the input power. Well, percent's on this side, and there's 50. So I'm looking across. I'm right at the top, which hopefully you recognize as a maximum point. So the part that would give me that information is the maximum. The second question is asking, or is talking about when the motor starts losing its efficiency when it hits 3 amps. So there's 3 amps, and that happens to be on the x-axis, which means that we're finding that information from the x-intercept. The third part says, as the input power current grows beyond 1 amp, so 1 amp again is right there, the motor becomes less efficient. So as I'm moving towards the right from 1, the efficiency is decreasing. Because it's decreasing, that would be the decreasing interval. So the second question is talking about temperature, which is in degrees Celsius, and that's on the y-axis, and hours after midnight. So these are hours on the x-axis. It says it was getting warmer between 2 a.m. and 2 p.m. So 2 a.m. would be right here, and 2 p.m. is 14 hours after midnight. So saying that during that time it's getting warmer, the temperature is going up, and that is happening where the graph is increasing. So that is our increasing interval. The second one says the temperature was above 0 between 8 a.m., which is right here, and 8 p.m., which is right here. Again, those 8 p.m. would be 4 hours before the end of the day. Full day is 24 hours, so that's 20 hours. And I hope you notice that those green marks are hitting on the x-axis, which means that that information is coming from the x-intercept. The third one says it was -3 at the beginning of the day. That is happening right there. And because that's on the y-axis, that's happening at the y-intercept. All right, so looking at number 7, it gives you a graph, and it says the graph shows population, which is on the y-axis, and the time in years since animals are introduced to an island. And the first question says, how many years does it take for the population to maximize? So I'm looking at this graph, and I notice that the maximum is happening right here. And so I'm kind of looking down this direction, and that's happening at about 4 years. And then the second part, B, says when will the deer population reach 0, which is going to happen here. So I'm looking along. It's hitting 0 somewhere between 5 and 6 years. So I'm going to say about 5.5 years. And then part C says how many deer were originally brought to the island. Well, that happened as time was starting in this particular case. These marks on the side are counting by 20s, so that's in between 60 and 80. So I'm going to say maybe about 70 deer. Okay, then we can move on to number 8, which is another great problem. We're talking about a baseball, and the y-axis is the height of the ball, and the x-axis is the distance away from home plate. So we'll go that. So it asks for the maximum height. So again, we want to look up, and we want to find the highest point on the graph. And when I look kind of over this direction, it's happening maybe around 82. You'll notice I'm putting these little squiggly marks. That just means approximately. Part B says, how far is the baseball when it reaches its maximum height? So again, that's happening around here. So I'm going to look down, if I can draw a straight line. It's between 150 and 165. So I'm going to call it 157. Again, I'm going to put that approximation. And part C says, how high off the ground was the baseball when it was hit? So I need to be looking over here, and it's clearly somewhere between 0 and 5, but that 3 right there is telling me that it was 3 feet off the ground. So I know that for a fact. I don't have to estimate. Okay, looking at number 11, we're talking about the cost of making items. So the x-axis is the number of items, and the y-axis is the cost. It says how many items should be the business manufacturer each day to minimize the cost. Well, minimize means lower. So I want to find the lowest spot on my graph, and that is probably right around here. So because I want to know the number of items, I'm going to look, and it's a little past halfway, so I'm going to say maybe about 8 items. How much does it cost per day just to keep the business running? So if they make 0 items a day, how much does that cost? Well, here's 0 right there. So we need to look up here the y-intercept, and it's halfway between 100 and 200. So it's going to cost this company $150 to make nothing. And then if business was, if the business was spending $600 per day, so we're up here now, how many items would it be making? I'm just going to follow that across, and then I'm going to bring it down. And it looks like, I don't know, maybe around 38 or 39. Okay. And then taking a look at number 12, these are all really similar questions. So we're talking about t-shirt sales. So this would be the number of shirts, and that would be the amount of money that they are bringing in. And I'm sorry, that's not the number of shirts. That is the cost of a shirt. It says, what is maximum revenue? Maximum means looking at the top. And when I drag that over, we are past 1100, but not quite to 1200. So I'm going to call that around 1120. But anything in that area would be okay. What price would they have to sell the t-shirts for to maximize their revenue? So I'm looking for that maximum, but this time I want to know how much they're selling it for, and that's happening right at $15. And it says, what prices make no revenues? Well, again, revenue is money. So where are they making $0? That's happening in 2 places. Obviously, they're making no money when they're selling the t-shirts for nothing. And they're also making no money when they're selling t-shirts for $30. My guess is because the t-shirts are worth $30. I hope that helped. Have a good day.